Lesson 6, Applications of Equations for Linear Relations. So for our first example, the slope of a line is 0.5. So m is equal to 0.5. And it goes through the point 2, 3. We want to find the y-intercept. So we have y equals mx plus b. So we know that m is equal to 0.5. But we don't know what b is equal to. That's what we're looking for. But we do know that it goes through an x and a y at 2 and 3. So we're going to plug in 2 and 3 as our x and our y. So y is equal to 3, m is equal to 0.5, x is equal to 2, and we're looking for b. Half of 2 is 1, and we're going to subtract 1, so 2 is equal to b. So our y-intercept is b, and our rewritten equation, now we always want to leave our equation with a y and an x. Those are our variables. We want them to be able to change. So we leave it as y is equal to 0.5x plus 2. So there's our equation. Example 2. Tiana has a contract with the town council to operate a wading pool. It's getting emptied, and by the time she's recorded some of the times to see when it's empty, and it needs to be emptied by 4 o'clock. So she's starting to empty it at 2:30. So we're going to make a table of values. We have our x's and our y's. Our independent variables is equal to our x's, and our dependent variables is equal to our y's. And our independent variable would be time. We're going to call it t. And our dependent variable is the depth of water, which we will call d. So, on the first day the pool is open, she starts the pump at 2:30. At this time, she measures the depth of the pool to be 32 centimeters. So before she does anything, our time is 0, and the depth is 32. 45 minutes later, so 45 minutes, she measures the depth to be 11 centimeters. Now we want to figure out when the pool will empty exactly and if it will be empty by 4 o'clock p.m. We want it to be empty at that time so that people can stay in the pool as long as possible. So we want to find our slope first. So we have y2 minus y1 for x2 minus x1. My y2 is 11 and my y1 is 32. Over 45 minus 0, which is negative 21 over 45. So we have our equation so far to be y is equal to negative 21 over 45 plus b. Now we don't know b, and I forgot to draw x, so we're going to plug in this point to figure out what our y-intercept will be. Just kidding, we already know our y-intercept. That's it. It crosses at 0 and 32. So we have our equation. We know our y value is d over 21 over 45 t plus 32. So there's the equation for our line. So we want to figure out when the pool is empty. So that means we're looking for d to be equal to 0. So we're going to plug that in. So 0 is equal to negative 21 over 45 t plus 32. We're going to minus 32 from both sides. So you have negative 32 is equal to negative 21 over 45t. We want to multiply both sides by 45 to get rid of the 45 on the denominator. So we have negative 1,440 is equal to t. Negative 21t. And now we're going to divide by negative 21. And you should get 68.6 to equal t. So at 68.6 minutes, let's just round it up to 69 minutes. The pool will be empty. So if you start at 2:30 and we want to add an hour and 9 minutes, it will be empty at 3:39. Now that's not really helpful for us because we want the pool to be empty by 4 o'clock. There's a lot of time there. So what we're going to do is we're going to take 4 o'clock, and we're going to subtract 1 hour and 9 minutes. So that would be 3 o'clock would be an hour, minus 9 more minutes. So we have 2 o'clock and 51 more minutes. So she should start emptying the pool at 2:51 p.m. Example 3. Charlie runs a bed and breakfast in Dawson City, Yukon. He has 2 thermometers outside. One is Celsius and one is Fahrenheit. So let's just do this out first. We're going to make our independent equal to x, which is, we're going to say Celsius because we use Celsius. And our dependent is y, and we're going to say is Fahrenheit. I don't know how to spell Fahrenheit. So let's call them C and F, lowercase. So Charlie's bed and breakfast, he's recording the maximum temperatures and the minimum temperatures. So if he's recording the temperature on the same day, that means that those temperatures are equal. So he has 32.6 degrees Celsius is 90.68 degrees Fahrenheit. And he also has negative 46 Celsius is negative 50.8. So we're going to plug these, or use this information to find an equation for our line. So we have to find our slope. So you have negative 50.8 minus 90.68 over negative 46 minus 32.6. If you simplify this, you should get a negative 141.48 over negative 78.6, and divide those two numbers, you get 1.8. So now we need to find our y-intercept. So to do that, we're going to use this point and this slope. So we have y equals mx plus b. Instead of writing y, we're going to write 90.68. We have 1.8 as our slope, and 32.6 is our x, plus b. Now we're going to solve for b. 32.6 times 1.8 is 58.68. We're going to subtract that from both sides. And we get 32 is equal to b. So the equation to find between Celsius and Fahrenheit, y equals mx plus b, we know that our y is Fahrenheit, we know that our slope is 1.8, we know that our x is Celsius, and we know our intercept is 32. So here's our equation. So for part B, we want to find the degrees in Fahrenheit when it is 0 degrees Celsius. So we're going to make C is equal to 0. But I also want to find when F is equal to 0. We're going to just do it for both. So when C is equal to 0, F is equal to 1.8 times 0 plus 32. So F is equal to 0 plus 32. F is 32 degrees outside. So 0 degrees Celsius is 32 degrees Fahrenheit. Oppositely, we can plug in a 0 for F. Now we solve for C. So we minus 32 from both sides. We have negative 32 is equal to 1.8 C divided by 1.8, and we get negative 17.8 degrees is equal to Celsius. So when it's negative 17, or when it's 0 Fahrenheit, it's negative 17.8 degrees. The next one is we want to find when Celsius and Fahrenheit is the same. And if you know off the top of your head, it's 40 degrees Celsius is equal to negative 40 degrees Fahrenheit. But I'm going to show you how to do this. So we want to show when F is equal to C. But because we can't solve anything with that, we're going to use this equation to solve for C. So we're going to put C, isolate our C variable. So F is equal to 1.8 C plus 32. We're going to minus 32 from both sides. So you have F minus 32 is equal to 1.8 C. Now we're going to divide by 1.8. So C is also equal to F minus 32 over 1.8. So the reason why we have to do this is we have to put c in terms of f. So rather than writing a c, we can write f minus 32 over 1.8. And now all we have is f, so we can solve for our variable. So we're going to multiply both sides by 1.8. So we have 1.8f is equal to f minus 32. We're going to minus f from both sides. So 1.8f minus 1f is 0.8f. And now we're going to divide by 0.8. And we get f equals negative 40. So negative 40 is when they are both equal.